For the third quiz, actually, I found that there was a typo in the problem. So I apologize. So the question was x with a parametric problem x equals t, y should be t squared, and I missed it. So I think we have tried to solve various ways, but it doesn't give you the answer, right? So I decided to give most of the score if you just procedure is right. So it doesn't matter whether you got the wrong answer or right answer. Because there was a typo in the problem. So as long as the procedure is okay, then you will get the score. Good. And anybody who has changed the problem to y equals t squared, if you have solved this way, raise your hand. Oh, I was going to give an extra point if you change the problem. So let's try to find the solution. So characteristic equation should be like x dx over dy, dy over y is dz over z, right? Or ln x is ln y is ln z. That means y over x is something like a v, y over z, z over x is u, you can set. Then say u is some function of v, or z over x is y over x, right? So if we substitute this, y over x is t, right? And z over x is simply t squared plus 5 over t. So that means phi t is simply t squared plus 5 over t. Or you can change, replace t by y over x. Phi y over x is simply y over x squared plus 5 y over x is y squared x squared plus y over 5x. So since u is phi, so z over x is actually y squared over x squared plus 5x over y. Or you can change it to z xy is y to the square plus 5x squared. So, but unfortunately, I made a mistake in the problem, so typo in the quiz. And next week we have a final. Oops. Final exam. December 11th from 14 to 15, 3 hours. So naturally you can prepare 3 pages of cheating sheet. So, as a final topic for this semester, we actually covered the part of the topic last 2 weeks before, but second order partial differential equations. Thank you. 3 hours. It's final, so it should be long. Partial differential equations. Oh, by the way, I think I probably have told you before, but about the engineering math competition, that I promised to give an extra point if you get award. And unfortunately, the engineering college canceled the competition. So, well, so be it. C'est la vie. French, that is life. So I was going to give you the extra point for those who got some prizes, but unfortunately, the engineering college canceled the competition. So typical second order partial differential equation is of this form. And this can be classified into 3 different cases. If b squared minus 4ac is greater than 0, it's called hyperbolic type. If b squared minus 4ac is equal to 0, parabolic type PDE, type PDE. And b squared minus 4ac is less than 0, is elliptic type. Elliptic type. So this must be something familiar from your middle school days, right? It's called subsidiary condition, or in Korean, 판별식. So for example, AR squared plus BR plus C equal to 0. So second order equation. If b squared minus 4ac is greater than 0, then 2 real roots, right? If b squared minus 4ac is equal to 0, we have a double root. 1 double root. When b squared minus 4ac is less than 0, we have 2 complex roots. So these are the well-known results that we all know from the middle school days. So we are going to utilize this property to transform the partial differential equation and find the solution. So before we actually try to solve the equation, I told you that it might be easier to, it is convenient to introduce a canonical function, two functions, u, x, y, free x, y. These are called canonical functions. Canonical functions. And such that z is z u free. Then I'm just going to repeat the results that we obtained before. So zx is actually, you differentiate z by u and ux plus z free x. It's called chain rule. I think you must be familiar with this. And zy, same. Zu, uy plus z free y. And I did that before, but I'll just summarize. Zx, you can find it from previous note. Z u x square twice of z u free ux free x plus z free x square plus z u x z free x y. Previous result. So I'm just going to repeat it today. I can copy, but I don't know where it is. And zxy, same as zyy, is same as before zuu, uy square, twice of zu free, uy free y plus z free y square, zu uy plus z free y, and zxy is zuu ux uy zu free ux free y plus uy free x plus zu uxy plus z free xy plus z free x free y. I mean, actually, I did that 2 weeks ago, so you can check the detailed derivations, detailed calculations. I'm just writing down the main result. Then azxx plus bzxy plus zzyyy can be written as alpha zuu, beta zu free, gamma z free plus delta zu plus epsilon z free. So alpha is actually aux square, puxuy, cuy square. Beta is 2a ux free x plus b ux free y, uy free x, to c, uy free y, gamma is au free x square, b free x free y, c free y square, and delta is auxx, puxy, cuyy, epsilon is a free xx, p free xy, c free yy. Then so let's try to find out the hyperbolic case. So let's start with the second order equation. A b squared minus 4ac is greater than 0. That means we have two real root for this equation. AR squared plus PR plus C equal to 0. Right? So let's say R is lambda and nu. Then we can set uy over ux as lambda, free y, free x as a mu. Then what happens? Because lambda and mu are solutions of this, right? Lambda, mu, solutions of this equation. AR squared plus PR plus C equal to 0, right? So that means we can set this uy ux squared b ux uy c is equal to 0, right? Because lambda is ux over uy. We have set this. Or ux squared b ux uy c uy squared is equal to 0, right? So this is 0. That means alpha is 0, right? And likewise, a free x free y equals square, b free x free y plus c equal to 0. So that means gamma is equal to 0 too. So hyperbolic type of equation can be PDE becomes beta z uv is some f minus delta zu minus epsilon zf free. The PDE partial differential equation can be simplified considerably. So let's try to find some example. Am I going a little too fast? But this is actually the review of the part we have done the last time. So the characteristic equation becomes ux over uy equal lambda, and vx over vy is become mu, right? That's the characteristic equation. So ux minus lambda uy is equal to 0, and vx minus mu vy is equal to 0. So it looks familiar, right? This is like a capital P, zx, capital Q, cy is r type of equation. And this solution can be P over dx, Q over dy, r over dz, right? So, but since r is 0, we have only two equations. So this equation can be written as this: 1 over dx minus lambda over dy, or dy over dx is minus lambda, right? So dx over dy plus lambda equal to 0. Likewise, vx minus mu vy is equal to 0. You can transform into 1 over dx minus mu over dy, or dx over dy is minus mu over dx over dy plus mu is equal to 0. So this is also one of the things that we like to use to find the solution. And so let's have an example. zxx plus xzxy minus 6x squared zyy is x minus 1 zx. So a equal to 1, right? B equal to x. C is minus u 6x squared. So let's check the subsidiary equation. B squared minus 4ac is x squared plus 24x squared is greater than 0 unless 4x equal to 0, right? So it does have two solutions. It's a hyperbolic case. So let's try to find the r square plus xr plus minus 6x squared is equal to 0. So we can factorize r minus 2x, r plus 2x, 3x is equal to 0, or lambda is 2x, mu is minus 3x. So let's find that ux over vy, dx over dy plus lambda is equal to 0, right? So what is that? Dx over dy plus x 2x is equal to 0, or dy plus 2x dx is equal to 0. And the solution is y plus x squared is some constant. So let's say this is u. Another solution is dx plus dy plus mu is equal to 0. That is dx dy minus 3x is equal to 0. dy minus 3x dx is equal to 0. If we integrate this, it has y minus 3x squared over 2 is constant, so it's free. So we found u and v. So we can set u is equal to xy plus x squared. V is y minus 3x squared over 2. Let's say x inverse cx is x inverse cu ux cv vx is x inverse cu. Ux is 2x, cv minus 3x, twice over zu minus 3zv. We have alpha equal to 0, gamma is equal to 0, beta is 2ux vx x, b is x, ux vy, uy vx plus minus 12x squared, that's c, 2c, right? u y v is vx vy, right? Let me see, v beta vy uy vy. So that is ux is 2x minus 3x plus x. Ux is 2x times 1. Uy 1 vx minus 3x minus 12x squared. So minus 12x squared minus x squared minus 12x squared is minus 25x squared. Delta a uxx b uxy c uyy. Obviously, if we differentiate u twice by y, it's 0. So a is 1. So uxx is 2, right? xx is 2. And if we differentiate x and differentiate by y, it's again 0, right? And epsilon a vxx b vxy c vyy is minus 3. So minus 25 z u v plus 2zu minus 3zv is 2zu minus 3zv. So they cancel each other, and we have x squared. Zuv is equal to 0. So solution is something like that. Phi u plus psi v. That is the solution, right? So we can write down solution as, general solution as z as phi y plus x squared plus psi y minus 3 over 2x squared. So even though the partial differential looks complicated, it can be solved. Need time for copy. Okay, let's go parabolic type. B squared minus 4ac is equal to 0. That means we have double root. So AR squared plus BR plus C equal to 0. We have some lambda. So we have only one solution, right? So dx over dy plus lambda equal to 0. Lambda is obvious, minus 2a over b. So from this you have u equal to c1. And obviously alpha and beta is equal to 0. You can see that. Example, cxx minus 4x zxy plus 4x squared zyy is equal to 0. So a equal to 1, b equal to 4x, c equal to 4x squared. So that means lambda minus 2x squared is equal to 0, or lambda is 2x. So dx dy plus 2x equal to 0, y plus x squared is c1, constant. So we can set u is y plus x squared, right? How about free? So parabolic condition set only one condition for u, right? So free we don't know. Free, unknown. Still. So we can set arbitrary. So let's say free simply by x, or any function you like. I'll just say x. This is simplest case. And let's see. Beta twice of ux 3x minus 4x ux 3y uy 3x plus 4x squared uy 3y. And we have a set for u is y plus x squared, 3 is x. Then any partial derivative of 3 by y is 0, right? So this will be 0, and this will be 0. So we have twice over 2x minus 4x over uy is 1, 3, 1 is 1, right? It's 0. So beta is equal to 0. How about gamma? Gamma is a 3x squared, b 3x 3y, c 3y squared. Of course, 3y squared will be 0 because we have set x, 3 as x. This is also 0, right? This is 1. So gamma is 1, right? Delta a uxx Puxy, Cuyy. Obviously, this is 0, this is 0, and this is 2. This is 2, right? So this is 2. Epsilon, AVXX, PVXY, CVYY. Everything is 0. So solution is, so PDE becomes something like that. Original PDE was what? C UV VV plus 2 CU equal to 0. So we can try the separation of variable. So we can try the separation of variable. Z as u, function of u, phi, function of phi. Then ZVV plus twice of ZU becomes UU with twice of U plus phi is equal to 0. Or phi over v double prime minus u plus twice of u prime right? So this is a function of v only. This is a function of u only. So left half side is a function of u only, and right half side is a function of v only. Then what is the result? Some constant, right? So it must be some constant, say minus k, or dv square, d square v plus kv is equal to 0, and dv du dv is 1/2 over ku. So this solution will be something like exponential twice of ku, right? This solution will be sine and cosine. So v will be some function of sine root kv, cosine root kv. So general solution will be something like this. So this is second. Z can be written as sum over k exponential k u over 2 c1k sine root k v c2k cosine root k v, and you substitute back to u and v. U was y plus x squared, v was x, right? The solution is something like k over exponential 2 over k y plus x squared c1 sine root kx plus c2k cosine root kx. And this constant can be determined by some suitable conditions, initial conditions or boundary conditions. So later, K will be determined by some condition. And the partial differential equation you covered consisted of about a few weeks ago, Black-Scholes equation from financial engineering. It's a particular type of parabolic type equation. So this can be using this generalized Fourier series. So we are not going to get into more details, but for suitable problems, you can check out any engineering math books for partial differential equations, and you might be able to find some examples. So we're almost done. So any questions? The final type is the elliptic type. So that means there is no real root. So the possible case is if AR squared plus BR plus C equal to 0, the root will be something like this. Lambda plus minus I mu, right? So characteristic equation will be dx dy plus lambda plus minus I mu is equal to 0. And of course, ux over uy plus lambda plus I mu, vx over vy with lambda minus I mu. So let's consider the example. Is zxx y squared zyy plus yzy is equal to 0. So a equal to 1, b equal to 0, c equal to y squared, right? So b squared minus 4ac minus 4y squared is always less than 0, right? For y is non-zero y. So r squared plus y squared is equal to 0. Y must be, r must be plus minus iy, right? So say dx characteristic equations. Dx plus iy is equal to 0, right? So dy over y plus I dx is 0. So solution is like a y ln y plus ix is constant, or ln y exponential ix is constant. So let's say u as y exponential ix, v as then minus ix, right? Or it is convenient to change u as y cosine x, v as y sine x. It's the same, right? So instead of using this, let's change it into this. It's a new u and v. Then I think my problem. Okay, so that is how it is. So here. So if we move this minus dy, let's see alpha AUX square BUX UY CUY square, and P was 0, of course, right? Because P was 0, A was 1, C was Y square, right? So we say U is Y cosine X, so A is equal to 1, so Y minus sine X square plus C is Y square, and UY is cosine X square is Y square. Beta twice over A UX VX B. We don't need to consider B because this is 0, right? So we didn't bother to consider C. 2C VY UY twice over UX is minus Y cosine X, Y sine X, twice of Y square, VY, UY is cosine X, and VY was sine X, 0, right? Comma A Vx square B Vx Vy C Vy square. A was 1, so Vx square is Y cosine X square, and B is 0, C is Y square, and Y is sine X, right? So this is Y square. Delta AUX BUXY CUYY. This is 0. YY is 0, right? If we differentiate twice, it is 0. So if we differentiate twice, we have minus Y cosine X, right? Epsilon is AVXX BVXY plus CVYY. So if we differentiate twice, this is 0, this is 0, this is minus Y sine X. So we have y square CUU plus CVV plus minus y cosine x cu minus y sine x cv is equal to 0. Right? Let me see. Plus, this is minus, minus. Oh, and sorry. This is not 0, but I think minus y gy from the original equation. How about this? cy cu uy cv vy is cu cosine x cv sine x. So this is actually minus y cosine x cu minus y sine x cv. They cancel each other. So the final equation is something like this. This is a 2. This is a 3. So we have a y square cuu plus cvv is equal to 0. There's a partial differential equation we need to solve, or cuu plus cvv is equal to 0. So anybody taking 전자장? Raise your hand. And or have you learned about the Laplace equation? So this is actually Laplace equation, right? It's in UV. Right? Correct? The Laplace equation is something like partial x square phi plus partial y square phi is equal to 0. That's the Laplace equation in electromagnetic theory. And same equation, but it's just UV. So Laplace equation is a typical case of elliptic type partial differential equations. So we can try the separation of variable technique again. So we can try the separation of variables. So z as a uu vv, then w vv plus vw uu is equal to 0, or u over u double prime is minus v over v double prime is equal to 0, equal to some constant, say minus k. So u double prime plus k u is equal to 0, v double prime plus minus k v is equal to 0. So u can be like cosine root 2k u, cosine root 2k u, v is exponential root 2k v exponential minus root 2k v. So general solution is something like this. Sum over k c1k sine root 2k y cosine x c2k cosine root 2k y sine x times t1k exponential root 2k y sine x cosine x or sine x. This is cosine root 2k cosine x, and this must be sine x plus t2k exponential minus root 2k y sine x. So that's a general solution for the Laplace equations. And so basically, the topic I wanted to cover for this semester is over. And so I will give you some homework. Find 5 PDEs PDE I don't know, PDEs for hyperbolic, parabolic, and elliptic each, and find general solutions. So that's your final homework. So dig out any engineering math book to try to find 5 for each, so 15. 5 hyperbolic equations, and try to solve for general solutions, and 5 parabolic type, and 5 elliptic type. For any equation is okay. So you just find any engineering math book. I think they will have some sections about partial differential equations, and you can find some solutions. So that's it. And before so this is actually the end of class, officially. And I have some announcements. We have opening. My lab has openings for 0 number of intern students. Sorry about the terminology that intern student used by Chogu, but intern students. And employment will be for 1 year. Like 2021 to 2020 to 12. 1 year, and monthly salary over 60만 원, 100K, right? And office space will be also provided. Responsibility. Grading of next year's engineering 공학 수학. Grading of engineering math for 2020. And also some assistant for quantum computing project. It's not big, but small. There will be some small work for the students for the quantum computing project. So you can send the application to me by the end of before final. Maybe before when? 언제까지 하면 되죠? Christmas? Before Christmas? We need time to interview, so by December 18, send to me or one of my students your transcript. Transcript is 성적표. Just send me an application, just email with the transcript, and we will decide few students for the interview. And officially, we are going to make an announcement in either 과사무실 or in elevator. But you are my students, and for this class, so I'll just let you have the first opportunity for this news. So before, that's it. So maybe I should just turn off the